The first moment of the universe, when time itself wasn't born yet. Imagine standing at the very beginning of everything, before stars, before space, before even the concept of before. What would you see? The truth is, nothing. Because at that moment, time and space didn't exist yet. Scientists call this unimaginable instant the Planck time, the very first moment after the Big Bang, occurring around 10 seconds after the birth of the universe. That's 0.0000000000000000001 seconds. A fraction so small that it's beyond human comprehension. At that point, the universe was smaller than an atom, but incredibly hot, with a temperature of about 10 curies Kelvin. It was a state so extreme that all the fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force were fused into one single unified force. This was a time when the laws of physics as we know them simply didn't work. Einstein's general relativity couldn't describe it, and quantum mechanics couldn't explain it either. It's a gap in our understanding, a boundary beyond which our theories break down. Physicists call this the quantum gravity problem. Somewhere in that first instant lies the secret of how space, time, and energy first emerged. That's why scientists are still searching for what they call a theory of everything, a theory that unites relativity and quantum physics to finally explain what truly happened at or before the Big Bang. After the Planck era ended, the universe began to expand and cool. As it did, the unified forces started to separate. First gravity, then the strong nuclear force, and eventually electromagnetism and the weak nuclear force. Tiny quantum fluctuations in that hot, dense energy field became the seeds for everything that would come later. Galaxies, stars, planets, and life itself. Within fractions of a second, quarks and electrons appeared, combining to form the first building blocks of matter. Over billions of years, these particles would come together to create the stars that light up our night sky, and ultimately, the atoms that make up you and me. It's mind-blowing to think that every atom in your body was once part of that blazing, chaotic moment, the same event that gave birth to time, space, and everything in existence. When we look at the stars, we're not just seeing distant suns. We're looking back in time, glimpsing the faint echoes of that first spark, that cosmic awakening when the universe took its very first breath. From a moment shorter than a heartbeat of time, eternity unfolded. The Big Bang isn't just a story of explosions and expansion. It's a story of transformation. From nothingness to everything, from chaos to order, from silence to the vast cosmic symphony that continues to play today. And maybe, just maybe, understanding that first instant, that single flicker called the Planck Moment, will one day help us understand not just where we came from, but why the universe exists at all.